Pull up your 3.6 part 1. This should already have been submitted this morning. We're going to use this as notes, as a reminder of how to do things. I'm going to talk about other stuff more than what's just on this assignment, just so we kind of keep our minds refreshed and that sort of thing. But what's the first thing I should do when I have any of these problems? I should pull up my cheat sheet. Very good. I'm going to grab my cheat sheet, put it right here. Okay, so there it is. These questions are asking us today to find what? X and Y intercepts. Okay, that's just what these focused on, was to find the X and Y intercepts. That's where the graph crosses the X and Y axis. How do we write our answers if we have an X or a Y intercept? Like with a comma as an ordered pair, right? So each one of these, we're going to do the same thing. We're going to find the X-intercept. We're going to find the Y-intercept. Remind me, please, how do you find the X-intercept? What does your cheat sheet say? Set the numerator equal to 0. So I'm literally going to take the numerator, that's the one on top, and I'm going to say X minus 5 equals 0. Everybody with me? Okay, so I'm going to add 5 to both sides. Add 5. So my X-intercept, when I plug in what? I get X equals 0, right? So when I plug in 5, or I shouldn't say that. When I set the numerator equal to 0, we'll just say it like that. Where does the graph cross the x-axis? At 5, 0. All right, does anybody have any questions about that? How do you find the y-intercept? What do you plug in for x? 0. You literally plug in 0 for x's. When I plug in 0 for x, what am I left with? Negative 5 over 6. So when I plugged in 0 for x, I got out negative 5, 6. Is it okay that I got a fraction as my answer? Absolutely. There is a place on the graph that is negative 5/6. It's in between 0 and negative 1. That's okay. How did you know you're only going to have one x-intercept if you had one at all? Just by looking at your problem. Because the exponent is 1. Good. All right, number 2. X-intercept. How do we find the x-intercept again? Remind me. Numerator equal to 0. So 3x equals 0. How do I solve this? Divide both sides by 3. Good. And x equals how much? 0. Is that an okay answer? Yes. Is there a point on the graph that the x value is 0? Yes. So you would write your ordered pair as 0, 0. Where is that on the graph? Where? The origin. Mm-hmm. And then to find the y-intercept, guys, remind me, what do I do again? Plug in 0. Okay, so I'm going to plug in 0 here and 0 here. Actually write this down so you don't get yourself confused. What is 3 times 0? 0. Over what? Negative 5. Guys, what do we know about 0 over negative 5? The answer is 0. What would happen if 0 is on the top? On the bottom. Undefined, there'd be none. So again, the origin is the y-intercept. That is very possible that the x and y-intercepts are the same. That's okay. That is allowed. Everybody with me? Okay, let's scoot along. Whoops, next page. Okay, this one's a little longer. Don't worry, like I said yesterday, about the larger value and smaller value. That was for WebAssign purposes. But again, guys, how do you find the x-intercepts? Set the numerator equal to 0. How many x-intercepts am I going to have here? How do you know? Because the exponent is 2. So I have x squared minus 2x minus 15 equals 0. Can I factor this? What are the factors of 15 that multiply to give me negative 15 but add to give me a negative 2? Good. Negative 5, x plus 3 equals 0. So I have x minus 5 equals 0. X plus 3 equals 0. Agreed? So I have 2 x-intercepts. I have one at positive 5 and I have one at negative 3. Correct? How do I write those? 5, comma, 0, and negative 3, comma, 0. Questions? All right, so let's go ahead and do the y. How do you find y again? Plug in 0. So 0 here, 0 here, 0 here. What am I left with? Negative 15 over negative 7. Well, two negatives give me a positive. Very good. So my y-intercept is 0, comma, 15 over 7. Good. If I asked you guys what the domain or vertical asymptotes were, where would you look? Think about domain or vertical asymptotes. Look at the denominator. Good. How do you know if there's holes? If factor top and bottom and stuff crosses out. Good. We need to be able to, when I say that, you need to be able to know, oh, this is where I look. This is where I look. This is where I look. Very important. All right, next one. Again, we're going to do the same thing. How do you find the X-intercept? What do you do? Set what equal to 0? Numerator. 5 equals 0. Is that a true statement? No. So what do you think that tells you about your intercept? There is no X-intercept. None. It doesn't touch, and that's okay. You put did not exist, that's fine. That's what WebAssign wants you to say. So how are we going to find the y? Plug in 0. So 0 here, 0 here. What am I left with? 5 and negative 6. So when I plugged in 0 for x, I got out negative 5, 6. Perfect. Questions? Do you guys see the difference between when there's just a number on top and then a number like we had 3x that has a variable with it? That will give you an answer if it has a variable with it. It's just a number, it's not going to. All right, if I asked you, just real quick, can you guys tell me the horizontal asymptote for this one? Question, it didn't ask you for it, I'm just asking. Look at your cheat sheet. How do you find horizontal asymptotes?
It's 1.
Why is it 1?
Because it's the same.
All right, you compare the numerator degree to the denominator, 2 and 2, right? Mm-hmm. It's the same. So then your horizontal asymptote is going to be y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Good. Okay, so let's go to X-intercepts. Set the numerator equal to 0. Okay, so either way you guys want to do this, you can factor it or you could just move it over and solve. Doesn't matter. But I'm going to have 2 here. It's going to be a x equals negative 3 and x equals positive 3. So how would you guys write those two intercepts? Negative 3, 0, and 3, comma 0. Good. And again, how do we find the y-intercept? Plug in 0 for our x's. So 0 here and 0 here. What am I left with? Negative 9 over 0. Guys, can we have 0 in the denominator? No. So are there any y-intercepts? None. You can say none or does not exist, however you want to say it. Just make sure you don't tell me it's 0. Undefined is fine. Yep, that's fine. All right, let's look at number 6. Some of you said to me, well, this one doesn't work. It does work, I promise. How do you find the x-intercept? You equal what to 0? Numerator. X cubed plus 27 equals 0. I can't factor this or anything, but can I solve it? Yeah, if I move 27 over, I get x cubed equals negative 27. Guys, you can take the cube root of negative numbers. Can't take the square root of negative numbers, but you can take the cube root. What number times itself 3 times gives me negative 27? Not 3. No. Negative 3. Negative 3 times negative 3 is 9 times negative 3 is negative 27. So this is going to have an intercept at negative 3, comma 0. It's only imaginary if it's a even root, like 2, 4, 6, something like that. That's not imaginary. That is real. How would you guys find the y-intercept? 0 for x. So 0 here, 0 here. What are you left with? 27 over 9. Okay. Does that simplify? To what? To 3. So your answer here would be 0, comma 3. Huge difference between 3, comma 0 and 0, comma 3. Huge difference. When I look at this, guys, just on initially looking, I'm not asking you to do anything, but I'm asking you to just look, okay? Is there a slant asymptote for this problem?
Yeah,
How do you know?
because the exponent, or the
exponent on the top.
The exponent on the top is more than the exponent on the bottom. Good, very good, guys. If I asked you what the horizontal asymptote was, what do we compare?
There's no horizontal asymptote
How do you know that?
because the numerator degree is greater than the denominator.
Good, 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 good. That's the kind of stuff you guys need to be on the ball with. All right. Find the horizontal and vertical asymptotes. Oh, they're asking us a different question. This is how your test is going to be. Going to give you a fraction. I'm going to give you a rational and say find the X and Y intercepts. The next question will say find the vertical and horizontal asymptotes. One question will say find the slant asymptote. I'm not going to ask you for everything for just one problem. Yep, that's why we're practicing like this. So if I ask you for the vertical and horizontal asymptotes, now we got to shift our mind. We got to think, wait, how do you find vertical asymptote? What do? You set the denominator equal to 0. So x minus 8 equals 0. I'm going to add 8 to both sides, and I get a horizontal asymptote at x equals 8. Agreed? I'm going to go one step further, and I want you guys to also tell me the domain. What is the domain of this function? It could be everything in the world except for negative infinity, comma 8, union 8 to infinity. It could be anything in the world except for 8. Your domain and your vertical asymptotes go hand in hand. Horizontal asymptote. This is a good question here. Horizontal asymptotes, they ask you to compare the numerator degree and the denominator degree. What is the degree of the denominator? What's the degree of the denominator? 1. Good. What's the degree of the numerator? 0. Guys, this is x to the 0 power. What's anything to the 0 power? No. 1. If you have a constant, we learned about that at the beginning of the year. If you have a constant, that just means you have x to the 0 power. So your denominator degree is 1. Your numerator degree is 0. What is the comparison between those two? Yep. Okay. 0 is less than 1, right? The denominator degree is greater than the numerator. What happens when the denominator degree is bigger? There's no horizontal asymptote? Or is it y equals 0? What does your cheat sheet say? Okay, so it's y equals. Your horizontal asymptote is always going to be y equals. Your vertical asymptote is always going to be x equals. Look at your cheat sheet. This is going to be the hardest one for you guys to remember. If the numerator degree is less than the denominator degree, is the numerator degree less than the denominator? Yeah. Yes. So what's your answer? Yeah. Y equals 0. Make sure you guys are aware of that. All right, vertical and horizontal asymptotes. How do you find the vertical ones? Set the denominator equal to 0. So x squared minus 16 equals 0. I'm going to go ahead and factor that. X plus 4x minus 4. Yeah? So I have two vertical asymptotes. One at x equals negative 4 and one at x equals positive 4. Agreed? Okay. So what is my domain? I'm going to go ahead and answer one extra question. What is my domain? Negative infinity to negative 4. Good. Union. Negative 4 to 4. Good. 4 to infinity. Very good. How do we do the horizontal asymptote again? Nope, horizontal asymptote. Compare the numerator to the denominator. Numerator to the denominator, the degrees. What's the degree of the numerator? 1. What's the degree of the denominator? 2. 1 is less than 2. If the numerator degree is less than the denominator degree, what is my horizontal asymptote? Y equals 0. You guys have got to get that into your brain. Vertical and horizontal asymptote. Again, where do we look? Keep forgetting. Vertical asymptote. Set the denominator equal to 0. Okay. All right, so I can't factor this. If it was a minus, I could, but I can't. So I'm going to move the 1 over. 9x squared equals negative 1, right? Divide by 9. So I have x squared equals negative 1/9. Can I take the square root? God bless you. Yeah, you can. What's the square root of 1? 1. What's the square root of 9? 3. What am I missing? Why is there an I? Because it's negative. Do we know how to, or can you, is it possible to graph imaginary numbers on our regular XY coordinate plane? Have we done it? When have you graphed imaginary numbers on a regular XY? You can't do it. So are there any vertical asymptotes here? No, there's none. If you get an imaginary number, you guys can't graph imaginary numbers on a normal XY plane. All right, horizontal. How do you find horizontals again? Compare the numerator degree to the denominator degree. I got the same answer here. 1 and 2, right? 1 is what then 2? So your horizontal asymptote is y equals 0. Make sure you have y equals. Make sure you have y equals. Let's just say, it's not the case, but let's just say you had 8x squared plus 1 over 9x squared plus 1. What would your horizontal asymptote be in this case? What do you do with the degrees? You compare them, right? So top is 2, bottom is 2. What do you notice about those two numbers? They're the same. So when the numerator degree and the denominator degree is the same, it's the leading coefficient at the top over the leading coefficient at the bottom. So it's y equals 8 over 9. That's if this was the case here. If the degrees are the same, and guys, make sure that it's in standard form, meaning the highest exponent is first. But if the degrees are the same, you just compare the numerator to the denominator. Good. All right, what about this one? Vertical asymptote, what do you do? Set the denominator equal to 0. We're doing 100 of these at one time because this is super important. So now I'm going to... Okay, we can add 1 to both sides, but I want to make sure that we don't miss any answers here. So can I factor this? What times what is x to the 4th? X squared and x squared. What times what is going to give me my negative 1? Negative 1, positive 1, right? So now when I solve these, what's going to happen when I solve this? It becomes imaginary, right? If I move 1 over, it becomes negative, and I'm going to take the square root, so we don't have to worry about this one. But can I factor this one a little more? X plus 1, x minus 1 equals 0. So I have vertical asymptotes at x equals negative 1 and x equals positive 1, correct? How would I write the domain for that, ladies and gents? Go, negative infinity. Perfect.
Union negative 1 to positive 1.
Perfect.
Union
1 to infinity. Good. Guys, when we first started interval notation, y'all had absolutely no clue how to even start. And then now it's just like old hat. You guys do this no problem. It's awesome. Really, really good.
For the first part,
Uh-huh.
can you just do like X to the 4th?
Yep. You could go like this, x to the 4th. Move the 1 over and you get 1, right?
Yeah.
Then you take the 4th root. The only thing you have to remember is what has to go in front of your answer. Plus or minus. Yeah, because it's an even root. If not, if you just put 1, then you miss one of them, right? So you just got to remember, if it's an even root, 2, 4, 6, you got to have plus or minus. Horizontal asymptotes, remind me for the 19th time. You compare the numerator and denominator degree. The degree of the numerator is 2. The degree of the denominator is 4. 2 is less than 4. So your horizontal asymptote is at y equals 0. This right here, guys, is how you show me your work on your test. Takes all of about 2 seconds. But you can show me that you understand how you found your answer. All right, here we go. These are a little more complicated, but guess what? We know how to do this. How do you find vertical asymptotes? Denominator equal to 0. So 4x squared plus 10x minus 14 equals 0. All right, this is a factoring problem, guys. It's just a little bigger than the ones we've been doing. No biggie. What should I look for first? GCF. Take the GCF out at the beginning, guys. Just make your problem easier. What goes into all 4 of these numbers? 2. I'm going to divide everything by 2, and I'm going to bring it out in front. So 4 divided by 2, I got 2x squared. 10 divided by 2 gives me 5x. 14 divided by 2 gives me negative 7, yeah? Okay, a little easier now to work with. My A term is not 1, so what should I do here? Okay, A times C. That 2 is still out in front here, so I have negative 14. Are there factors of negative 14? That'll multiply to give me negative 14, but add to give me a positive 5. Plus 7 minus 2. Now, guys, can I just go ahead and set each parenthesis equal to 0 yet? No, because my A term is not 1, so I need to divide everything by 2. Everybody with me? Okay, so my 2 is still out in front. 7 doesn't divide by 2 pretty, so it's going to become my coefficient, 2x plus 7. 2 divided by 2, nice and pretty, so I have x minus 1 equals 0. Now can I solve? Set each piece equal to 0. So 2 equals 0. True? No. 2x plus 7 equals 0. Can I solve that? Sure can. Move 7 over. Becomes 2x equals negative 7. Divide both sides by 2, and I get x equals negative 7 halves. One of my vertical asymptotes is at negative 7 halves. The other one, x minus 1 equals 0, is at x equals 1. Correct? These are my 2 vertical asymptotes. Now, if I was going to write the domain based on those, tell me what the domain is. Negative infinity to negative 7 over 2. Union, negative 7 over 2 to 1. Union, 1 to infinity. Perfect. Perfect. And then how do I find my horizontal asymptotes? Compare the numerator degree to the denominator. So numerator to the denominator. The degree of the numerator is 2. The degree of the denominator is 2. Oh, it's the same. So it's going to be at y equals the leading coefficient of the numerator 12 over the leading coefficient of the denominator, which is 4, which simplifies to 3. So your horizontal asymptote is at y equals 3. Good. Very good, ladies and gents. Last one. Again, this question is asking for vertical and horizontal asymptotes. Vertical means I set the denominator equal to 0. So my vertical asymptote is at x equals 8. Tell me the domain. Negative infinity to 8. Union, 8 to infinity. Good. How do you find the horizontal? Compare the degrees. The numerator degree to the denominator. The numerator degree is 2. The denominator degree is 1. In this case, the numerator degree is greater than the denominator. What's my answer here? None. Very good. So let's go over the 4 things that we really focused on today. X and Y intercepts. How do you find the X intercept? Set the numerator equal to 0. How do you find the Y-intercept? Plug in 0 for all the X's. How do you find the vertical asymptote and therefore the domain? Denominator equal to 0. And how do we find the horizontal asymptote? Compare the degrees. Good. Good. Does that feel a little better than it did last Friday? Okay, so your homework tonight is the 3-6 Part 2 WebAssign. We'll do the same thing with that. We'll go through the whole thing tomorrow. And I will give you back your quizzes so we can go over that and answer questions. Sound good? All right, good job today, guys.